Assalamu alaikum and hello everyone. In this video, I'm going to show you guys how to calculate the flow of water through soil using Darcy's law, okay? Which is Q equals to KIA. So this is the same question as you've seen in the slide before. All right, so we're gonna do this together. Okay, so let's go here. Seepage, which is referring to the movement of water through soil. Okay, seepage is occurring through the sandy layer underneath the concrete. Okay, so seepage is occurring here. Okay, so this is the sandy layer, and we have this concrete dam over here. So concrete dam is empangan concrete, and below the concrete dam we have sandy layer, satu lapisan pasir, and then seepage is occurring through this layer. Seepage berlaku melalui lapisan ini. Alright, and down here we have impervious rock. What is impervious rock? It means a layer of rock that is impermeable, tidak telap air. So which means air or water cannot flow through this layer. Okay, and also given in the question, you see here, this is the water level. Kan ni empangan kita. So this side we have water, okay, with H1 equals to 16 meter is given here in the question, 16 meter, and this is H2. Okay, this side we also have water. H2 is 2.3 meter, and H3, which is the thickness, okay, which is the thickness of the sandy layer, it is 0.75 meter. And this length here, okay, is 45, and hydraulic conductivity or K, it is 0.09 centimeter per second. So in this example, we have to calculate the rate of seepage per unit length of the dam, and the unit is meter cubed per hour per meter. Okay, so how to do this? First, let's list down, kita senaraikan semula the important values that are given in the question. Okay, so we know that, okay, H1 or the upstream water level is 16 meter, and then we know that the downstream water level is 2.3 meter, and the thickness of the sandy layer, ketebalan lapisan pasir, is 0.75 meter, and the length is of the concrete dam is 45 meter, and given, okay, diberi K or the hydraulic conductivity is 0.009 centimeter per second. So we have to determine rate of seepage, okay, rate of seepage per unit length of the dam. So rate of seepage here is Q, and in this example, we are going to use Darcy's law. So based on the slides, we know that Q equals to KIA. Okay, so K, this is given. So we have to find I as well as A. So what is I? What is I? I is the hydraulic gradient, and it is equal to delta, okay, can you see? Delta H over L. And then we know that A is the area. Okay, first, let's find hydraulic gradients. So how to calculate hydraulic gradients? So basically, to find delta H, it is equal to, okay, H1 minus H2. Okay, H1 minus H2. So we know that the difference between H1 and H2 is the hydraulic gradient. Okay, so H1 is 16 meter. Okay, we're gonna write here 16 meter minus H2, which is 2.3 meter. Okay, divide by L. So L is the length where the hydraulic gradient occurs. Okay, so this length, which is equals to 45 meter. So over 45 meter. So when you do this, you plug in these numbers into your calculator, then you'll get I equals to, so you got I equals to 0.304, and this is dimensionless, okay? No unit for I. So the next one, we have to find the area. So how to find this area, okay? So to find this area, first, you have to imagine this concrete dam to be in three-dimensional. Okay, or in Malay, untuk mencari area, kita kena bayangkan concrete dam ini dalam bentuk 3D. Okay, so let me draw this for you. Okay guys, so as I said just now, in order to find the A, okay, the area of the seepage, the area where the seepage occurs, area yang mana seepage itu berlaku. So we have to imagine that our concrete dam is in 3D. Okay, so because the one given in the question, this is 2D. So to find or to calculate the A or the area, we have to imagine our concrete dam as a 3D dam. Okay, so I draw this again for you. Okay, so this is the concrete dam. This is the same concrete dam. All right. So to find the A, so where is the A actually? Okay, area to area yang mana? Okay, so this is a concrete dam. This is the sandy layer just now. Okay, sandy layer where the seepage occurs. Okay, where the seepage occurs. All right. And then this is the height of the sandy layer, isn't it? So this is the height of the sandy layer, and given in the question, it is equal to 0.75 meter. Okay, so the area that we are talking about is this area. Okay, I'm going to use a green highlight to highlight the area for you. Okay, so we are looking, we want to calculate the area of this area. Okay guys, so this is the area that we are interested in, the one highlighted in green. So we know that the thickness of the sandy layer is 0.75 meter. So therefore, we want to know the length of this. Okay. For your information, the length of this side is always 1 meter. Okay, panjang bahagian ini adalah always 1 meter. Okay, because we want to know the seepage at every 1 meter into the dam. Okay, so it is that way. Okay. If you look at this picture, it is like the the length into the concrete dam. So this is 2D. So this is in 3D version, which is, I hope, a bit easier for you to understand. Okay, so therefore A equals to 0.75 meter times 1 meter, isn't it? 1 meter is this length going into the dam. Okay, so this is always 1 meter. Okay, so therefore our area is very simple, equals to 0.75 meter square. All right, so we got A already, and we got I, and K is given. So it's just that we need to convert. Okay, we need to convert the unit of K, because the one given here is 0.009 centimeter per second. Okay, so to convert K to 0.009 centimeter per second, to convert this to the SI unit, so we need to use SI unit, which is meter per second. Okay, meter per second. So we have to multiply this by 36. Sorry. Okay. To convert centimeter per second to meter per second, this is basic mathematics. So we have to multiply by 36. Okay. So therefore K equals to 0.324 meter per second. All right. So now it is very straightforward. We have to calculate Q. Okay. Therefore, I'm sorry, I'm writing all over the place. So therefore, Q equals to KIA, and then we know that K equals to 0.324. Okay, and I is 0.304, and our A is 0.75. Okay, so plugging all these numbers into your calculator, therefore you'll get Q equals to, you'll get Q equals to 0.074 meter cubed per hour per meter, or you can also write like this: Q equals to 7.4 times 10 to the power of -2 meter cubed per hour per meter. So this is the rate of seepage per unit length of the dam. So okay guys, so this is our answer highlighted in green. Q, or the rate of seepage per unit length of the dam, is 7.4 times 10 to the power of -2 meter cubed per hour per meter. And then in this example, we use Darcy's law, okay, to calculate the flow of water through soil. Direct application of Darcy's law. Okay, I hope this video helps you to understand this topic better. If you have anything, please let me know. And thank you for listening. Bye-bye.